We are doing non-homogeneous linear differential equations. Now in the previous video we did homogeneous differential equations. Just recall that when we have a differential equation that the right hand side was equal to 0. Now as you can see here, from now on in a non-homogeneous differential equation, on the right hand side we will get either one function or the finite sum of k functions. So what we're going to learn now is then when we do a non-homogeneous differential equation and they ask us for the general solution, we will always have that y is the complementary function. Now that's what we did in the previous videos. That's when you solve the homogeneous differential equation. Plus, in this video, we'll do the particular solution when we solve the general solution of a non-homogeneous system. So, what we're going to use the method of undetermined coefficients to find the particular solution. So, what is very important, we can only use the method of undetermined coefficients if our gx is a constant, a polynomial function, an exponential function, a sine or cosine function, or a finite sum and product of these functions. We will never use the method of undetermined coefficients when our gx is any of these forms. But more on that later while we're doing the examples. So, to illustrate the method of undetermined coefficients, we must always look at the form of our gx. So we will look at the forms on this side of our gx, whether it is just one function or the sum of finite functions, and that will give us an indication of the form of the particular solution. So what do I mean by that? So we're going to study this table where specific forms of gx along with the corresponding form of the particular solution is given. Now, it looks complicated, but as we do the examples, you'll actually see that there is not much to study. It is very difficult, very easy to follow. So let me just explain what I mean by this table. If you have a linear non-homogeneous differential equation, so there you can see that we have our second order differential equation, but since we don't have 0 on this side, we know that gx is a constant. So what we will do later, we will first solve the homogeneous linear differential equation. So we'll solve the complementary function first, and then after that we will use gx to solve our particular solution. Now let's look at the table. What is the specific form of gx in this example? The specific form, it is a constant. So the corresponding form of the particular solution will be a constant. That will be our assumed particular form. More on that just now, why I'm saying assumed. Now let's look at the next example. The specific form of gx here is 3x squared. There's our differential equation equal to gx, 3x squared. Now, as you can see, that's a polynomial. Hence, the assumed solution of y particular will be a polynomial. So as you can see there, if gx is a polynomial, the corresponding form will be a polynomial. If gx is linear, the corresponding form will be linear. So the same for if it's a cubic equation, our corresponding form will be a cubic equation. Now just one of the forms that you really have to study not to get confused with this. If we have our differential equation and it's our gx is 3 sine 2x. Now let's look at the table. If we have 3 sine 2x, the corresponding form of y particular will not only be b sine 3x, but you also add a cos 3x. So whenever your gx is either a sine mx or a cos mx, you will always add both of these, cos and sine. So hence in this form, this example, I have 3 sine 2x as my gx, so my assumed particular solution will not only be a sine or b sine 2x, it will also plus a cos 2x. And the same if I'm getting 3 cos 2x, I will also have cos x plus sine x. Now, when you get, for instance, e to the mx, your corresponding form for yp will be a to the mx. If you get now a product, so I'm getting a product of a linear times e to the mx, my corresponding y particular will be linear times e to the mx. The same for product of a quadratic times e to the nx will be a quadratic e to the nx. But just make sure again, whenever you have sine by itself, say with a product of a quadratic, you will not only have sine, but you have cos and sine. But remember, the form for a quadratic will be a quadratic here, but these two will be different. So, and then the same for cos, but more on that as we're doing examples. So let's just look at this one. If the form of gx is 3x squared e to the 4x, so just note here we have a product. This 3x squared is a quadratic form. So what do you see? You will have the corresponding quadratic for y particular times the corresponding for e to the 4x, which is just e to the 4x. But those was just to explain that quickly. Now, why did I say assumed? Now, the next sentence is very important. Just see if you can follow what I'm saying here. Remember what I said earlier. We're always first going to solve our complementary function. How? That is from the previous videos. That's when we solve our homogeneous differential equations. So whenever you get non-homogeneous, you will first solve your homogeneous differential equation and then your particular. Now, the next sentence is extremely important. If the assumed particular solution, so if we have assumed particular solution, and we look at the associated complementary function, and some of the terms of this assumed particular solution is duplicated in our complementary function, then our assumed particular solution must be multiplied by, now I'm just saying this to make it more clear, it must be multiplied by x to the n, where n is a natural number. Now what is power n? N is the smallest power of x that will eliminate duplication. Now, that is a mouthful. Let me explain it with this example. Let's look at this first example here. So we have our linear second order differential equation. We see it's non-homogeneous. Now, what did I say just now? You always need to solve your homogeneous first to get your complementary solution. Now we're going to go quickly through this because I did explain everything clearly in our previous examples on homogeneous. We make it equal to 0, as you can all recall. We then get our auxiliary or characteristic equation. Just to quickly mention, remember your second derivative will be m squared, your first derivative m. But then if you just have y, you will just have 1. And then so on for higher derivatives. But that you should all be familiar with from the previous videos. Now what I do, I'm going to solve this. What do I get now? I factorize. I get m plus 3, m minus 2 equals to 0. So just remember, you get two distinct real roots. And just recall, if you have two distinct real roots, your complementary function will be c1e to the negative 3x plus c2e to the 2x. So make 100% sure you understand this. I did solve my complementary function first. Now what is my next step? Now you go back. So remember I said you look at the form of gx. What do you see here? Gx is a linear equation. Let's go to our table. A linear equation, even though the plus c is not there, it is linear. So what is the corresponding assumed form for y particular? It is ax plus b. So my particular assumed form will be ax plus b. A common mistake students make, since gx is just 2x, they will assume that the particular form is just ax. No, you need to do the whole linear form. Now, let's just compare our complementary and assumed particular form. So this is very, very important, and that's why we did the complementary first. We're always going to compare these for duplicates. What do I mean by that? If you look at ax, nothing is duplicated here. Duplicated, they look the same. No, they're not. B, is anything duplicated here? No. So no function in the assumed yp is duplicated in the complementary. So that means that we are safe to use yp as ax plus b. So I will just explain later what I've done in these steps. I just want you all to really understand first what we are doing here with the particular solution. Let's look at this example quickly. You have your linear fourth order differential equation. Now, it's also often that I see that students are not familiar with this form in brackets. Just remember that means the fourth derivative. So you have your your fourth order linear homogeneous differential equation, in this case non-homogeneous, since it is not equal to 0. But what did I just say? Whenever you get non-homogeneous, you in any case for the general solution, you always need to solve the homogeneous differential equation first. So let's just recap that quickly. So we have m squared minus m to the 4 minus m squared. We take out m squared as a common factor, m squared minus 1. Just remember before, because we have m squared, m equals 0 is a repeated root. Don't forget to actually write it down for yourself so that you remember it in the test. Then here we have m is 1 or m is negative 1. Now, just to recap from the previous videos, a repeated root will be c1e to the 0x, but repeated you must times by x. So it's c2x to the 0x. Then we have m equals 1, m equals negative 1. They are distinct, different real roots. And there I have my complementary function. Now let's go to gx. So I have 3 sine 2x plus 2x squared e to the negative x. That's why the reason why I now said that my gx is equal to g1x plus g2x. Now what we're going to get later, we're going to get yp1x plus yp2x. So for each one, we need that associated or corresponding particular form. Let's first look at g1x, which is 3 sine 2x. Now recall what I said from the table. 3 sine 2x. Do not make the common mistake students make. Don't just use sine. Remember I said whenever you see sine and cos, you will add both of them, cos and sine. So let's just go back here, and what do we see? We see that sine, 3 sine 2x, the corresponding assumed particular form is a cos 2x plus b sine 2x. And that's why I did use the brackets there, because I want you to understand this is P1, yp1. Now let's look at our next form, 2x squared e to the negative x. Now recall what I said earlier, this is a trinomial, but even though we just have that form, you need to put the corresponding yp as your full trinomial, cx squared plus dx plus f. Common mistake students will see that, they will just put cx squared. No, we need to solve the whole trinomial. Then we have e to the negative x. So again there, that is my assumed yp2. Now, just to recap, why do I say assumed? Because I want to see, let's do this term first, if anything in this term is duplicated in my complementary function. But what do I see? Nothing is duplicated. So they're not the same form. Let's look at yp2 assumed. Now I'm going to say a very important thing. It is advisable that you immediately distribute that term in to give you this term. But what you must understand now, I'm still using this brackets here because you're going to see this as one term. What do I mean by this? While you're seeing that this one is duplicated in the complementary function over here, that's the only one that's duplicated, since these are e to the x and we don't have a duplication here. This one is the only one that's duplicated. That means I'm going to times by x. Since e to the minus x is duplicated, I'm going to times by x to eliminate that duplication. But what must I times by x? Definitely not this term. Nothing was duplicated. Not only this term, but the whole bracket. Why? Because this is one term actually. So what do I do? When I times by x here, I get cx cubed e to the negative x. When I times by x here, dx squared e to the negative x. When I times by x here, fx e to the negative x. Now let's check if any term or function in yp assumed is duplicated in y complementary. So remember, y complementary, very important for our comparison. And what do we see? Everything is fine. Nothing is duplicated. And that is our y particular. So what are we going to do then? When we write down our general solution, we will have our complementary, this one, plus our particular, this whole solution. And later on, we learn then how to solve these coefficients. So, on to a next one. So, before we get to that, I am sure now that you are getting the better of this table and you realize that there is not much to study. It is just about the form of gx that you are then going to decide on the corresponding form of y particular. Constant, constant, linear, linear, quadratic, quadratic, and so on. The only two that are a bit different, if you have sine, corresponding form y particular will be that sum. Same for cos, e to the mx, e to the mx, and then all these products. So just familiarize yourself with the table before you start with some questions. Now let's get on to 4a. What do you see now in the test? You see they ask for the general solution of the non-homogeneous differential equation. What do you write down for yourself immediately? You need complementary plus particular always for a general solution of a non-homogeneous differential equation. So we always want to do our complementary solution first. So let's run through that. That's then equal to 0. You have your auxiliary or your complementary function. Your characteristic function. What you're going to do, you see here that b squared minus 4ac is less than 0, which means complex roots. You do your formula. B squared, it's minus b plus or minus b squared minus 4ac over 2a. I'm not going to go through all the steps. You should be familiar with this. You get minus 1 plus or minus 1i. In other words, my alpha is -1, my beta is 1. So from the previous video, you know that your complementary function is then e to the alpha x minus 1x c1 cos beta x plus c2 sine x. Now again here, it is now advisable, so you understand better, to multiply or distribute the e to the negative x in. So here we have our complementary function, and we're going to compare that later to our assumed particular. Now let's look at our form for gx. We see that we have 4 cos x plus 2 sine x. Now, what I said earlier from the table, the corresponding y particular form for 4 cos x will be a cos x plus b sine x. But now I'm going to say a very important thing. Then the corresponding form for 2 sine x will be, now this is a common mistake what students make, will be c cos x plus d sine x. But why don't you have to do this? Because if you take out cos as a common factor, you get a plus c. If you take out sine as a common factor, you get b plus d. What do you all see here? That we actually just get constant cos x plus constant sine x. And for that reason, you don't have to do this. You will just say that your assumed particular solution is a cos x plus b sine x. So I hope that is clear. Now, very important, now I am going to compare that to my complementary function. So let's compare that quickly to our complementary function. So what do we see? Our assumed particular solution is this. Our complementary function is here. Now let's see, is anything repeated? Let's check this. Is this term repeated in our complementary function? No, because of the e to the negative x. These are not duplicated. The same here, because of the e to the negative x, that's not duplicated. So what do we see? Our assumed particular is actually the correct particular form that we're going to use. And then later on, we're going to solve a and b, and final step, we will write our general solution. Now, just on to our last one. So I want you to really pay attention here, because here we have a glitch here. We have y a double derivative plus 4 is 3 sine 2x. Now just recall what I've mentioned a lot in the previous videos. If when we do our auxiliary or our characteristic equation, the second derivative of y is m squared. First derivative is m. And then when we have y, we will just have m to the 0. So it's just 1. So we have a problem here then for our auxiliary equation. What about that 4? Because students often confuse it. So if you have this, your auxiliary will be m squared plus 4. That should be clear. So this auxiliary cannot be m squared plus 4. So we have a slight dilemma here. What are we going to do? Please remember this, that you will take this across, and then work from there. So that's very, very important. So I've just mentioned here as well, if you have your differential equation, but you have these terms in x, you need to realize here that this is you're going to do your auxiliary equation from here. You need to take the x terms across. So from now on, any constants or functions in x, you will take across. So what do we have here now? Our auxiliary or characteristic equation is only m squared is 0. That means that m is 0, but please don't forget it is a repeated root because of the square. So your complementary will be c1 plus x c2. Why the x? Because of the repeated root. And remember, because m is 0, we actually have e to the 0x, and that falls away. So let's just see what our y particular, the assumed y particular, will be. Now recall, this is your gx. Now let's look at this. This is g1x. From the table, let's see without looking if you can see it. It will be, since it's sine, it will be a cos 2x plus b sine 2x. And just please remember, this angle is 2x, so we'll have 2x and 2x here. Now just make sure you understand this. G2x is my -4. Recall from the table, it's a constant, so the assumed particular form will just be constant. So let's look, let's compare our particular assumed with our complementary. Here's our complementary solution. What do we see is repeated? Is anything repeated here in the complementary? No. Anything repeated here in the complementary? No. The c repeated? Yes, because they have the same form. Remember, your constants can be different. They don't have to be exactly the same, but this is a constant, so that's repeated. So what must I times here by? I must times by x. So what do I see when I times by x? So make sure you understand this. When I times by x, I will get cx here, but then it is repeated over here. So cx is repeated over here, so now I must times by x squared. And that's where the sentence came from that I mentioned in the earlier, that you must times your term by x to the power of n. What is n? It is the smallest power that will eliminate duplication. X to the 1 is not going to eliminate duplication because you're going to get cx, which is then duplicated there. So you need to times by x squared. Let's see if it will eliminate duplication. And also remember, you just times that term where you need to eliminate the duplication from. So if I times that, I get cx squared, but I still have these two terms, and there is my y particular. So that is quite a mouthful for undetermined coefficients, but more on this in the next video, when we will do some more test and exam type questions on using the method of undetermined coefficients. But what we will then specifically also do that, I will explain to you in detail how we will be solving these arbitrary constants. So that is the end of non-homogeneous differential equations, part 1.